We'll look at even and odd functions. That's our first part. By definition, a function f of x is said to be even if f of negative x gives us f of x.
Sir.
Hold on.
Oh, okay, it's okay.
2, a function f of x is said to be an odd function if f of negative x is equal to negative f of x. And 3, a function is said to be neither even nor odd if it's not even or odd. Examples. State whether the following function are even, odd, or neither. A, f of x is equal to 2x squared minus 3. B, f of x is equal to x power 3 minus 3x. C, f of x is equal to x squared plus 4x. So let's check. So to check for the first one, our first thing is to write f of negative x. F of negative x means on the right hand side, where there is x, we take negative x, square and subtract the 3. This is going to give us 2. When you square a negative, it becomes positive. But this thing that we have here is the same as f of x. Hence, f of x is even. That's what the definition of being even is telling us. That even if I substitute a negative x where there is a positive x, if I still get the same question that I had, the function I get is the same as the function I was given to check if it is even or odd, then what we have is an even function. Second, f of negative x is negative x to the power 3 minus 3 minus x. This is the same as negative x power 3 plus 3x. If you look at this function, it's not the same as the function that we have, the f of x. So because it's not the same, we have known that it's not even. It's not even important to indicate that it's not even. Just after we know that it's not even, by checking here, you can see is not the same as f of x, so it's not even. You proceed and factor out the negative, so you get x3 minus 3x. If you check what we have in the brackets now, it's exactly the same as f of x. So this is negative f of x. What does it mean? It means that f of x is an odd function. C, you get f of negative x is equal to negative x squared plus 4 negative x. This is the same as x squared minus 4x. If you look at this function, clearly it's not an even function because what we have now is different from our f of x. But when we factor out a negative, we'll get negative x squared plus 4x. Again, what we have inside is not the same as f of x. So f of x is neither even nor odd. Done. Do we have questions? No questions. Okay. One-to-one functions. A function f of x is said to be a one-to-one function if f of x is equal to f of y, implies that x is equal to y. What does this mean? Examples: determine if the following functions are one-to-one or not. A, f of x is equal to x minus 2 over x plus 3. B, f of x is equal to x squared plus 7x. C, f of x is equal to 2 plus x plus 1 over x minus 4. Are these functions one-to-one? Or maybe not. Let's see. For the first one, f of x is equal to f of y will imply that x minus 2 over x plus 3 is equal to y minus 2 over y plus 3. Cross multiply x minus 2 y plus 3 is equal to y minus 2 x plus 3. Xy plus 3x minus 2y minus 6 is equal to xy plus 3y minus 2x minus 6. So 6 and 6 will be taken away there. Then xy and xy will also be taken away. We'll remain with 3x minus 2y is equal to 3y minus 2x. So put the x values together. 3x plus 2x is equal to 3y plus 2y. That is 5x is equal to 5y divided by 5 divided by 5. This will imply that x is equal to y, and the definition says so, that if you manage to get there, then f of x is a one-to-one function. Do we have questions? Okay, we move. F of x is equal to f of y implies that x squared plus 7x is the same as y squared plus 7y. This is the same as, maybe we can factor out x here and get x plus 7. Do the same to y and get y plus 7. But this means that so if normally here, the mistake that we make is doing this or doing this. This is the first thought that we come up with if you're in an exam and you're alone. Because you're unable to relate this, you direct away say x is equal to y or x plus 7 is equal to that. If you try to do this, this function automatically becomes a one-to-one function. If you look at it like that. The question is that the case? So you'd say, okay, for here, because, so you don't base your reasoning on this one. You base your reasoning on the nature of the function. So you say, but this is only true for x is equal to y. And hence a 1-to-1 function. So after I factor out like that, I don't have to equate x is equal to y, the other inside is equal to the other. No. The only thing I'm going to say is that this statement here is only true for x is equal to y. Because of the 7x and the 7y there, the function becomes a 1-to-1. Hello.
Question.
Mhm.
What if you manage to factorize the x squared plus 7x? You find the factors actually, and also this side you do the same. Is it going to be what is the 1-to-1 function?
Yes. What makes it 1-to-1 is, let's try -1. What is f of -1? That would be -1 squared plus 7 multiplied by -1, which is 1 minus 7, which is -6. If this function is not a 1-to-1, when we use 1, we must get the same thing. Now, if we use 1, we'll have 1 squared plus 7 by 1, which is 1 plus 7, which is 8. The square disturbs the function from being 1-to-1 because it gives the same value, whether negative or positive. But when there is an x which is not squared outside, that x will help us change the numbers for us not to get the same thing.
So, sir, may I believe that one is not the 1-to-1, because if you're going to find two things whereby say you find x squared and also the y squared, that one. But the rule there is saying that it should only be x equals to y. How is
Yeah.
Maybe you can try to.
I'm also beginning to believe. I'm thinking of sketching this. If we were to complete the square, and try to sketch, this guy will become 7x plus 7/2 squared minus 7/2 squared, meaning we'll have x plus 7/2 squared minus 49/4. If you get to 0 to get the values of x, they code the x-intercept, we'll get 49/4 square root. We'll get plus or minus 7/2. So x is going to be -7/2 plus 7/2, which is 0, or -7/2 minus 7/2, which is -14/2, which is -7. So that if we sketch, it is running from 0 to -7 with the intercept -7/2, -49/4 as the minimum turning point. So this graph will go like this, turn up like there. I'm convinced now. So this is not right. So that Now, except when you say the factors, we may not get the factors by solving, can we? Yeah, we could. Would have just said x plus 7 is equal to 0. So x is 0 or x is -7. Then they would have to just help us to sketch. Okay. So this means that for this type of a question, actually, we cannot use the formal definition to disprove that it's a one-to-one or not, to disprove the one-to-one notion. I think we just need to use the nature of the function. This function is a main-to-one, because if you have a value here, it will be gotten from this value of x and from the other value of x, all going to one number, meaning it's not a one-to-one, but a main-to-one. So it's not a one-to-one function. Okay. Yeah. So now, what's the easiest method of knowing whether this guy is a one-to-one or not? So we'll say, for now the function is squared, automatically it's not a one-to-one. But how do you get to show? The easiest will be to sketch. And use the graph as you're working.
So
Uh-huh.
I think here, like the way you did, where we say x, then open bracket, x plus 7 is equals to y, then y plus 7. Here, when you simplify it, it would be probably it would be x is equals to y. Then again, you get x squared minus y squared. So those ones for x, quite alright, x will be equals to y. But we are going to get another value, which is x is equals to negative y. And since our definition is saying that only x, we want x is equals to y. That, so meaning for the other one, which is x is equals to negative y, it is disproving for the entire question. That's what I see.
The negative y is failing to come out. Since if you factor out on the left, you must factor out on the right also. So we'll get something like this. If you try to distribute this thing, you get both values, x is equal to y, or x plus 7 is equal to y plus 7.
So as in, for this one, before you even reach there, what if you say this one, the y squared, you move it where there is x squared, then you find difference of two squares. Then for the 7x, since 7 and this one, the 7y, the 7 can cancel. That's what I mean, as in, if you can differentiate the.
Okay, so I want you to keep this also so that you don't lose it out. Okay, meaning I want to delete it. So right on the next page. I like that thinking. X squared plus 7x, y squared plus 7y. Then we get x squared minus y squared is equal to 7y minus 7x. Then here we have x plus y. We also have x minus y is equal to 7y minus 7x. This is where now this is where now it jumbles. Because the 7y minus 7x is not becoming n0 unless when x is equal to y. Are we seeing that?
So I think that's the reason why at first I asked as in what if for the there from maybe you can move it from the actual question. Yeah, that one. Whereby this one, the x squared plus 7x, you try to find the factors then, and also for y squared, you try to find the factors. Actually, for this one, for the x squared plus 7x, you get the two factors. For
You
x.
get 0 and
one,
negative 7.
you get and also at this y squared, you get two factors. You find out that two factors they are matching. Then for the other one will be positive, the other one will be negative. That's what I was trying to say, probably.
If we find independent factors, even y will come out to be 0 and negative 7.
Yes. To me, I think this is 1-to-1.
It's not 1-to-1. The graph is saying no. So have you seen that if you get the factors of x squared plus 7x will be 0 and negative 7. The factors of y squared plus 7y will be 0 and negative 7.
And the factors equals.
Yes, or don't you say it's 1-to-1?
Because the factors are equal, so it's 1-to-1.
No.
Aside, it should be 1-to-1, Kylie.
It's not. Because that thing is never 1-to-1.
Maths is something else. But it's showing clearly that it needs to be 1-to-1.
No. The clear is here. How does something which is 1-to-1 gives you a cube of that nature?
I think our answer can actually be here, where you wrote the x plus 7 over 2 there, because since this one it is 7 and we cannot find a standard factor. So assuming, for instance, if we had x squared plus 4, we would have found positive and negative. We would have found positive and negative. But in the case of, since this one is 7 and its factor might be a fraction, but in the form, they should be in the form of negative and positive. That's why now we take the chance saying that a quadratic function cannot form a 1-to-1 function, because since it is a quadratic, it can either have a positive factor and a negative factor. That's what they think.
Your thinking is very correct. And it is matching what we are saying. This definition here cannot directly tell us whether this function is a 1-to-1, because it's limited in the fact that when you get here, the only next step you can make is moving to this step here. And this step here, we fail to conclude there. But if you come to this level, it means you have left the right-hand side, which is f of y. You're just attending to f of x. And the f of x which you're attending to is leading us to a point where we're trying to sketch it. When you get to 0, you get two values, the plus or minus value, which is 0 and -7. These two values are all giving us 0 as f of x, implying that the function is not a one-to-one. Because if it was a one-to-one, we're supposed to find a single value of x that is giving us 0 in the whole function. Now that we have 0 and -7 giving us 0 for the whole function, then we have two values going to 0, meaning it's a main to one. So the function fails to be a one-to-one. That's the situation that we find ourselves in. So whenever the function fails to be directly determined in the formula there, if you use the reasoning I almost used when we are starting, because when I reached here, I didn't want to use any other method, as in thinking all this way or the sketch way. That's why I had said that it's a one-to-one, because I was seeing x being equal to x, being equal to y, and x being equal to -7, and also y the same. So I was like, this guy's going to give me the same. And I tried some numbers, they were coming out to be different. So I was like, it's a one-to-one. But then you realize that if you try to use some numbers like -7 and 0, two numbers will give you the same thing. That's why trying examples is not sufficient for proving that something is one-to-one or not. Okay. This thing was almost cutting before I saved. So we need to do C as well. But we have less time. We may not finish C. No, I think we can finish. C, f of x is equal to 2. Is equal to 2 plus x minus 1 over, so x plus 1 over x minus 4. So it having f of x is equal to f of y will land us in 2x plus 1 x minus 4 is 2 plus y plus 1 y minus 4. Straight away the 2's will cancel, so we'll have x plus 1 x minus 4 y plus 1 y minus 4, cross multiply, x plus 1 y minus 4 y plus 1 x plus x minus 4, x minus 4, and then xy minus 4x plus y minus 4 is equal to xy minus 4y plus x minus 4. So the xy will go, -4 will go, and then we put the x's together and the y's together. So we'll have -5x is -5y, divide by -5, divide by -5. So we'll get x is equal to y, implying that f of x is a one-to-one function. Okay. So now I think we'll be logged out soon. So let's log out and log back so that we can agree on what you should do.